Hello viewers, welcome to another section of my tutorial, and I have a question in series and parallel resistance connection. So it says find the total resistance of the circuit below. We have in our first example, in our first question, a 2 ohm resistor, a 6 ohm resistor, 4 ohm and 3 ohm resistor connected in this electrical circuit as shown here. We have been asked to find the total resistance. Now, first thing, work away from the source. Here is the source. Make sure you work away from the source. So you first combine the resistors farther away from the source and you get closer to the source. So after, consider two resistors at a time. Consider two resistors at a time. So first of all, you can see that starting away from the source, we come to this side. Now we ask ourselves, the 4 ohm and the 6 ohm, are they connected in series or in parallel? Now you can see there is a node here, there is also another node here. So at that point, current is going to divide or add up. For that reason, 4 ohm and 6 ohm are not in series. Now you also traverse in their paths. If you don't meet any other electrical element aside the 4 ohm and the 6 ohm, then it means that they are connected in parallel. So when you traverse through their path, there is no other electrical element here. For that reason, 4 ohm and the 6 ohm are in parallel. So to write our solution, our 4 ohm and the 6 ohm are in parallel. So we find their effective resistance, RT, will be equal to their product, 4 times 6 over 4 plus 6, and this will give us 24 over 10, and that is 2.4. So you redraw the circuit, then combining 4 ohm and the 6 ohm. So we are going to have something like this. You have our 2 ohms, then our combined 2.4 ohms here. You have our 2 ohms here, now have our 3 ohms here, nicely like that. So we have combined the 4 ohm and the 6 ohm here. So right now we have to also combine the farther parts or farther away from the source. We have 2 ohm and 2.4 ohm. Are they in series or in parallel? Let's see. Here is not a node, but you have a node here, you have a node here. But in between 2.4 and 2 ohm, there is no node between them. Hence, you can say that 2 ohm and 2.4 are in series. So for our series connection, the total resistance will be equal to 2 ohm plus 2.4 ohms. So our RT here becomes 4.4 ohms. So we have combined this place. So we will redraw again. We bring our source, and finally we bring our 3 ohm, then our last resistance. So here is going to be 4.4 ohms, and here is going to be 3 ohms. Now with 4.4 and the 3 ohms, we can see that in between them there is a node here, there is a node here. So it means they are not in series. When you traverse through their paths, you are not meeting any other resistor or any other circuit element aside the 3 ohm and the 4.4 ohm. Hence they are said to be in parallel. Therefore our total RT, total resistance of the circuit, becomes the parallel resistance or parallel connection of 4.4 and 3. So you're going to have 4.4 ohms in parallel 3 ohms, and this is going to be 4.4 times 3 all over 4.4 plus 3. So when you solve this, what are you getting? You are getting 3 times 4, 12, remember 1, 3, 4, 12, 13.2 all over 7.7 ohms. So we can make it 132 over 77 ohms as our final answer. So this is a step-by-step way of going through series and parallel connection of resistors. Let's see the second example. In the second example, we have our 2 ohm resistor, we have another 2 ohm resistor and 1 ohm resistor. So we have to work away from the source. So our solution, working away from the source, you can see that you have to tackle this 2 ohm resistor and also this 2 ohm resistor. Now let's see. We can see that the 2 ohm resistor here and the 1 ohm resistor here, if you are considering these two, there is a node here, so they are not in series. And if I traverse through their paths, I'm also reaching this source. Therefore, 1 ohm and 2 ohm are neither in series nor parallel, meaning I can't consider these two resistors. Therefore, I'll come and consider these two. When I come here too, there is a node here, there is a node here. Therefore, 1 ohm and these 2 ohm they are also not in series. And since when I traverse their path, I'm meeting this, they are also not in parallel. Therefore, I have to consider the 2 ohms, the two 2 ohms resistors apart here. Now, there is a node here, so these two 2 ohms resistors are not in series, but if I traverse through their paths, I'm not meeting any other circuit element, therefore they are in parallel. Therefore, I'll have my RT here to be equal to 2 ohm resistor being parallel to another 2 ohm resistor, and this is going to give me 2 times 2 all over 2 plus 2, and it's going to give me 4 over 4, and it's giving me 1 ohm. I already draw my circuit, and I'll have my 1 ohm here, my source here, and I'll have my final 1 ohm here. Here will be 1 ohm. Here's my source. This 1 ohm is the parallel combination of these two and these two, while this one is from the original question. Here I can see that there is no node in between the 1 ohm and the 1 ohm, hence they are in series. So therefore my total resistance becomes 1 ohm plus 1 ohm, giving me 2 ohm as my answer. If you find this video helpful, kindly subscribe and also share. Thank you.